Now we're going to start using inverse trigonometric functions to solve trigonometric equations. Okay. Now I'm going to break this into two steps. Right now I'm only going to show you the last step because it's actually the easiest. So when we're doing the first step, which we'll learn next, our goal is to arrive at some single trig function equal to I don't care how many numbers. Okay. So as an example, we would want to arrive at something looking like this, okay? When we get to a single trig function equal to some number of numbers, here's how we solve it. X, the thing inside the sign, will equal, I'm going to write down all the places on the unit circle where sine equals 1/2. Usually there's 2, okay? So sine equals 1/2 at 30 degrees, and sine equals 1/2 at 150 degrees. Notice I didn't write them next to each other because I'm going to add something. Sine, if you remember the graph, is periodic. It repeats over and over and over again. So these are just the answers between 0 and 360. If I want all of them, I'm going to add plus 360k to both of these. Okay? Meaning k can be any natural number, 0, 1, 2, or the negatives, -1, -2, so forth and so on. So I'm saying that an answer is 30 degrees plus any multiple of the circle, any coterminal angle. And same with 150 degrees. So this is my list of all solutions. Okay. Now, another way the problem could be asked is I could be asked to find all solutions lying within a specific interval. Okay, so instead of infinitely many here, because k can be any whole number, I'm going to end up with just a finite list of solutions. Now, the warning with this is it's actually better to find all the solutions and then cut them down to size, or you risk missing some. So, I have a single trig function equal to a number. This thing inside the cosine, the 2x, is going to equal all the places on the unit circle where cosine is negative square root of 3/2. And that's 150 degrees and 210 degrees. Okay. Now I need to put the plus 360k on both of these. Now this is 2x equals. I want x equals. So now I'm going to solve for x by dividing everything by 2. So I get 75 degrees plus 180k and 105 degrees plus 180k. This is the list of all solutions to this trigonometric equation. Now I'm going to find the list of those that lie in this interval. So here's how I do it. I'm going to start with the first one, and I'm going to start by plugging in k equals 0. So if you plug in k equals 0, you get 75 plus 0 is 75. Is 75 in this interval? No. Okay, so now I'm going to go to k equals 1. If I plug in k equals 1, I get 75 plus 180, which is 225. Is that in this interval? Yes. So it gets written down as an answer. Now I'm going to plug in k equals 2. 75 plus 360, okay, which is 435. Is that in that interval? Yes. So it gets written down. Okay. Now I'm going to plug in k equals 3. 75 plus 360, 540. Okay? And that gives me 615. Is that in that interval? Yes. So it gets written down. Then I plug in k equals 4. 75 plus 720. Is that in that interval? No. Okay? So, I know I can stop now because I had a no at the beginning, then a whole bunch of yeses, then a no. Okay, and the yeses will always be together. So once I get a no on either end, I'm stopping. Now I'm going to go to this one. I plug in k equals 0, I get 105, answer is no. I plug in k equals 1, okay, I get 285, answer is yes. So it gets written down. I plug in k equals 2, I get 465, yes. I plug in k equals 3, I get 645, yes. I plug in k equals 4, okay, I get 825, no. Okay, So this is my list of all solutions to the equation that lie in that very specific interval.